Okay, on the last example, it ended with us asking to find the probability that he makes at least 5 throws. So at least 5 throws would be 5 throws or more. So it would be these, 7, 8, 9, these individual probabilities. And each one I'd have to either plug it into this formula and get this value and then add them up, or use the binomial PDF. But either way, I'd have to do it like 6 times. So there is a function that helps us with this. It's called the binomial CDF. If you remember the CDF function in the normal, it goes from a lower bound to an upper bound. Well, that's what the binomial one does. You input the n, number of trials, the probability of success, and then you input the lower bound and upper bound. That will calculate from x equals the lower bound, so these are inclusive bounds. That's kind of important to understand because in a normal curve, it doesn't matter if you include or exclude the bounds, but for this one, it does. So inclusive lower bound to inclusive upper bound. So to do this, the probability that x is between 5 and 10 inclusive would be binomial CDF n equals 10, probability equals 0.6, lower bound equals 5, upper bound equals 10. In general, they don't like calculator speak. They don't like you to use calculator functions. But if you use the word binomial, that gets you credit for that. If you say n equals 10, that gets you credit for that. Now, if you don't say the n, if you just say 10, if you just say 10, 1.6, 5, 10, you won't get any credit for that. But if you do this, you're good. This, you're good. Lower and upper bound, you get that point. And if you just type that in the calculator, it'll actually add up all 6 of those probabilities together. Excuse me. So menu. Make sure I'm down here, right? Menu, statistics, distributions. Got to go down a little bit here. Oh, I can't. I have a hard time clicking the calculator whenever I use when I use the touch. I think I can scroll down with the pen. So binomial CDF, option B. Number of trials 10. Probability of success 0.6. Lower bound 5. Upper bound 10. Or was it 5 to 10 or 6 to 10? I can't even remember. 5 to 10, so that's right. So that's 0.834. And if we had a little more time, I would actually show you that if you add up 5 to 10, it'll give you the same thing, but I don't want to do it, so trust me, it works. Example, free lunch. Suppose a local restaurant is running a draw an ace and win a free lunch promotion. When approaching the cashier to pay for your meal, the cashier shuffles a deck of cards and asks you to pick a card. If you draw an ace, you get a free lunch. Suppose the restaurant gets 250 customers on a given day. Find the probability that they give out 25 or more free lunches. So is this a binomial distribution? Binary, either you get a lunch or you don't. Independent, if the first person wins a lunch, it doesn't influence the other ones because you're going to shuffle the cards over again. Set number of trials, yeah, I got exactly 250 people coming in according to this. And the probability of success of a win is the same every time. Yeah, if you're drawing an ace, that's 4 out of 52. Probability is 4 out of 52 or 1 out of 13. So this is binomial. Find the probability that he's going to give away 25 or more free lunches. That's the probability that x, by the way, x is equal to number of free lunches in 250 customers. What's the probability the number of free lunches is 25 or more? So if I were to draw this distribution out, I might give away 0 lunches or 1. I might give away 24 or 25 or 26. and I could give away as many as 250. Very unlikely that we give out exact 250 lunches. Everyone would have to get an ace. So 25 or more is going to be this outcome all the way up to there. Now here, there's really a lot. I mean, those are 224 or 25 or something. I don't know. All right. So the binomial CDF is really going to save us a lot of time here. By the way, from what I have on my paper, I can just put down the answer. I have this, I have this, I have this. Here, I'm denoting the lower and upper bounds. These aren't zeros, So there we go. We're good. Function's going to be, oh my gosh, what's going on? Binomial binom CDF, number of trials 250, comma, probability of success 1 out of 13, comma, minimum lower bound 25, inclusive up to 250. There's a 10.8% chance that that's going to happen. I do need to make or I feel obligated to kind of make a comment. This is, with calculators and stuff, we just type that in and go. Before calculators, to do this, just to calculate this one probability, I would have to calculate 250, choose 25. Then I'd have to take 1/13 to the 25th power, because I want 25 successes. And I'd have to take 12/13 to the 250 minus 25, or the 225 failures. And in order to calculate this, it would be 250 factorial over 25 factorial over 225 factorial. Just for this. That's 250 times 249 times 248, blah, 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 all the way down to 1. Now granted, you're going to get lots of cancels here, right? But still, we're talking some huge number crunching. Before a calculator, these calculations were extremely, extremely difficult. But with a calculator and technology, it's just a snap. Part B, let x equal the number of free lunches on this day. Graph the probability distribution for x. So I'm going to graph this distribution. Now I need to calculate every single one of the probabilities. Obviously, that's not very, I'm not going to do it by hand. Let's do it with the calculator. So this isn't something you really need to know how to do, but, makes you strong. The hard part here is getting in 0 to 250, and I know there's a way to, if I can remember what it is, to put a sequence in or something. Menu, data, table, actions. I don't know. There's a way to do a sequence here. I guess I should probably try to figure it out on my own and not waste your time while you're watching the video. Guess I'm just going to keep looking. Generate a sequence. So here we go. So this is a shortcut way to do this. Otherwise, you have to type in 0, 1, 2, all the way down to 250. That would take you a long time. If you click this and you go to Menu, Actions, and insert Data, go to Data, and you go to Generate a Sequence. So the sequence is just going to be U sub n. I guess it's just going to, I don't know, is that n minus 1 maybe? Initial term 0. Does that work? That might work. There we go. I guess that worked. 1, 2, 3, 4. This is going to go all the way down to 250. Again, I wouldn't worry too much about this, but so now I want to calculate each of those probabilities. So I'm going to put in a formula, Menu, Statistics, Distributions, binomial PDF. Now, why do I want to do a PDF? Because I want to calculate each one of these individual rows. This is exactly. You use PDF when you want the probability of getting exactly that many successes. You use CDF when you want to get a range. So there's 250 trials. Probability of success is 1 out of 13. And then for this, I'm going to put in those X values. Enter. Again, this is amazing. The calculator just in a snap did all those factorials and whatever, I guess. So this is super, super small. This is 0.000 to the negative, so 8 zeros and then a 2. You can kind of go in here and see where the probabilities maybe get a little bit. Negative 66, that's even more uncommon, 122 successes. So let's see what it looks like. Let's make a graph. Data and statistics. So let's graph our X's. So our outcomes are anywhere from 0 to 250. Let's go to menu, plot properties, add a summary list, number 9. And we're going to put in those probabilities. See, the calculator doesn't do a very good job selecting the window because it doesn't know how to handle it. These probabilities are so small. And then these, it groups up 0 to 20. And so let's just put it individual. For bin settings, go to equal bin width, and let's select the width of 1. So this is going to be individual values. And now, it's really small here, so let's zoom this up. So as you can see, the probability that you're going to give away 80 or 120 or 200 lunches is really small. It's likely not to happen at all. So where are the meat of your outcomes? It's also very unlikely that you give away 0. You know, somebody's bound to win out of 250 people. There's the shape of the binomial distribution where you have 250 trials and a 1/13th chance of winning. Recognize it? I mean, this thing practically looks normal. I mean, it looks very symmetric, unimodal. Looks like it's normal. So we did that. Okay, next video.